A user asks about the revenue trend shown in the Q3 report. The answer is in a bar chart on page 7. Standard RAG never touches that chart. It only processes text. Multimodal RAG passes each image through a vision language model to generate a text description, embeds that description, and stores it in the vector database alongside the original image path. Now the chart is searchable, retrievable, and can be passed directly to the language model as context. Standard PDF loaders extract text and discard everything else. Images are skipped entirely. Tables are often extracted as garbled strings of numbers with no column headers because PDF table structure is not encoded as markup. For a technical report, where 40% of the information is in charts, diagrams, and tables, Standard RAG is working with only 60% of the available knowledge. Multimodal RAG closes that gap by treating visual content as a first-class retrieval target. The strategy has 3 stages. First, we extract images and tables from each PDF page using pdfplumber. Second, we pass each image through GPT-4o Vision to generate a detailed text caption and serialize each table into Markdown. Third, we embed the captions in table text and store them in Chroma alongside the image file path. At query time, we retrieve the most relevant captions, fetch the corresponding images from disk, and pass both the caption text and the raw images to the language model. We extract images using pdfplumber. For each page, we iterate over the image objects, extract their bounding box coordinates, crop that region from the page, and save it as a PNG file. The function returns a list of file paths to all extracted images. Each image is named with its page and image index, so we can trace it back to its source document and page number later in the pipeline. To caption each image, we encode it as a base 64 string and pass it to GPT 4.0 alongside a prompt asking for a detailed description suitable for a search index. The model describes the content, layout, labels, and any data visible in the image. A bar chart caption might read bar chart showing quarterly revenue for 2024 with Q3 reaching 4.2 million, the highest of the year. That description is then embedded and stored in Chroma. When a user asks about revenue trends, the embedding of their query matches the caption embedding. Tables are extracted and serialized to Markdown format. pdfplumber returns tables as lists of rows where each row is a list of cell values. We reconstruct the table as Markdown with pipe-separated columns. Markdown tables embed well because the structure is preserved as readable text. The language model also reads Markdown tables correctly and can reason about the values. We store the page number alongside each table so citations can reference the source. We index images by captioning each one and wrapping the caption in a LangChain document object. The metadata stores the image type flag and the file path to the original image on disk. The caption is what gets embedded and searched. The image path is what we use to fetch the actual image when this document is retrieved. We never embed the raw image pixels. We embed the text description of what the image contains. When a retrieved document has the image type flag and its metadata, we load the image from disk, encode it as base 64, and add it to the message content list as an image URL block. Text documents are added as text blocks. The final message content list contains a mix of text chunks and raw images. When we pass this to GPT 4.0, it can read both the text context and directly examine the images, giving it the richest possible context for answering visual questions. You now know how to extract images and tables from PDFs, generate searchable captions with GPT 4.0 Vision, serialize tables to Markdown, store everything in Chroma with image path references, and pass retrieved images directly to a Vision language model. In the next episode, we cover observability and tracing, how to instrument your RAG pipeline so you can see exactly what happened on every query in production. Subscribe so you do not miss it. See you in the next one.